One of the most useful things when using Maple is that you are having full access to all the calculations and variables which have been done during the calculation. So, contrary to, for example, a compiled program where you just, as a user, have access to the things that are shown to you, in Maple you also will have access to the variables which are stored in the program. So let's just switch quickly over to Maple and let's see what we can achieve with this procedure. So we are just using one of the examples which have been done here, and as you can see on the left hand side you see a lot of defined variables. All of those which are shown here, or most of them, are procedures, so functions more or less. Some of them are differently. For example, the store settings is the matrix which is shown here, where all the settings in the calculations are stored in between sessions. However, the most important variable which I've used in this program is not shown, and this one is called whatever you need. So you just start typing and Maple automatically recognizes which variables that are in the program. So if you just press enter here, you just see, well, not so very much. There's something which is probably defined or probably not. So let's just check what kind of type this variable is. In that case we do have the function whatType. And this is shown to be a table. Now, there are different kinds of variables in Maple which you can use. So let's just go to Maple Help, and there are some magnificent tutorials which you can use and go through. I really would recommend that you do that. And there is one specific which I would like to point you to, which is called data structures. There are different kinds of data types in Maple, where we do have, for example, sequences or sets, which is an unordered sequence of distinct expressions. We also have lists, which are ordered sequences of expressions. Then we have multisets, which I'm not going to go into now. You have some explanation about how to use set or lists. We of course have arrays, matrices and vectors, but the most important thing for us now is tables. A table is a collection of data which is indexed by something. So for example, you have the index and you have, for example, B, C and A, and you have the entries. And both can be accessed in Maple here. So there are these two kind of functions which we can have a look at. We have the indexes function, which shows which kind of indexes that are used in NODEMaple. Some of them do store input data, and some of them do store calculation results or output data. So let's just go quickly through that one. We do have both materials, material data O. Material data O just is used when you have more than one kind of material, while material data usually has the active material data stored. So let's just go through it. We can, of course, again try to have a look at what, for example, material data, what kind of indexes this one has. Oh, because, I'm sorry, what kind of type is that? This is also a table, so table can be nested, of course. And we also can have a look at what kind of indexes this one has. So again, this has more stuff. Of course, we also can have a look at what the entries are. which would show us the other part of a table variable. So this more or less just gives you the entries. The third function which is very important and useful is, beside indices entries, is the eval. Eval does show you both the indices and the entries in the table. But of course only the ones that are directly defined. If there is a subtable again, like here, section data, it will only show the incursive written name of the index once again. So the eval of whatever you need does have section properties, and this apparently is a set. So let's just have a look at what, for example, material data has. I'm going to use that one, which is already written here. Then this will show you both the indices and the entries of material data. So we do have a table, and this consists of a couple of indices and data values. In that case, the active material data, which is, let's just see where we find it. We do have a glued lamp timber. A glued lamp timber, this is that one. And we have a gamma M of 115, and the material values are those which are listed here. And in that case, they are also printed here, so we have the material properties. And all of these values actually are stored in that value, in that table. Whatever you need, material data does show this one. We also can have a look at the results. We did have, go back to that one. We do have the results. Let's just use that one now. So results again does have subtables, used code, we have the commands, and something which is directly defined also. So it's a mixture of directly defined values and subtables. So if we go further down the chain, try for example the used code. I'm sorry, we do have a syntax error here. Then this, also the used code, does shows that this again is a table with the indices 616 and 633 and 624. If you have a look here, 616 should be that one, 633 should be that one, and 624 should be that one. So that's the used codes in our case here. We do have, of course, more stuff, so let's just check that one. Let's just get the indices back. We can, of course, also use the commands. And they show those values. So used code 6.3, 6.2.4, used code description, combined bending and Excel compression, and of course you're also seeing that here. There are of course a lot of stuff here which are stored here that are not printed out, but you can just dig down for yourself, try to look what's defined here, and if you want to go further, have a look at GitHub and have a look at the code. Again, NODEMaple allows you to go very deep into the calculation and try and you really have direct access to all the variables that are used in the program. So that's that for this video, and we'll continue with the foster nurse in the next session.